Hello everyone, I'm Kirstin Petzer, a second year physical oceanography master's student at UCT and the Nansen Tutu Center. My supervisors for this project are Associate Professor Machu Bru and Dr. Taryn Lamont. As we have marine heat waves on land, so does the ocean. These events have been defined as marine heat waves. These warm water events have been described in recent years by Hobday Ekdahl as marine heat waves if the observed sea surface temperature is above the climatological 90th percentile for at least 5 days. Marine heat wave events have caused serious impacts on the marine environment worldwide, which is why marine heat waves have become the focus of extreme event studies in areas such as eastern boundary upwelling systems. The 4 eastern boundary upwelling systems seen here are important for fisheries worldwide due to the high productivity in these regions. This productivity is due to the presence of wind-driven upwelling. The upwelling, as you can see in this video, is driven by the wind blowing parallel to the shore. The friction exerted into the ocean in combination with the Coriolis force moves the surface layers offshore, allowing for cold, nutrient-rich waters to be brought from the depths. The Benguela upwelling system is off the west coast of southern Africa and stretches from the tip of South Africa to Namibia. The Benguela upwelling system is split into 2 subsystems, the southern and the northern Benguela. While in the same system, the upwelling in the southern Benguela is seasonal, while the northern Benguela has more permanent upwelling. The difference is due to the placement of the South Atlantic anticyclone over here. The anticyclone creates upwelling favorable southeasterly winds over the southern Benguela during the summer, but moves northward in winter, allowing for northwesterly airflow from low-pressure systems to flow over the southern Benguela. A key feature of the southern Benguela is its proximity to the Agulhas Current over here, where warm saline water leaks into the South Atlantic through eddies and rings. The closest upwelling cell being the Cape Peninsula upwelling cell over here. Because of the importance of upwelling to the socio-economic sustainability of the people in southern Africa, it is vital to understand the occurrence of extreme events such as marine heat waves in the southern Benguela. Because of the importance of upwelling on the socio-economic sustainability of the people of South Africa, it is vital to understand the occurrence of extreme events such as marine heat waves in the southern Benguela. To understand the occurrence of marine heat waves in the southern Benguela, I have used the Council for Scientific and Industrial Research, CSIR, Sea Surface Temperature Time Series. The wave rider buoy is based 5 kilometers offshore of Cape Point, which you can see over here, and has a half-hourly temporal resolution. The time series used in this study is from January 2003 to March 2020. As the buoy is based in the Cape Peninsula cell, this analysis will primarily be representing this upwelling cell. For the wind component, I used 5th generation European Center for Medium Range Weather Forecast Area 5 data. The UNV wind components have been generated by model forecasts and observations with a 0.25 by 0.25 degree spatial resolution. The hourly time series is over the same time period as the CSIR data. To have the spatial understanding of marine heat wave events, the Climatological Initiative Sea Surface Temperature Project data, i.e. the CCI data, over the Cape Peninsula cell will be used. The time series was created by using advanced high-resolution radiometer as well as a long-track scanning radiometer. The 0.05 by 0.05 spatial resolution has a daily temporal resolution and is also over the same time period as the CSIR time series. Here is the CSIR Sea Surface Temperature Time Series. The sea surface temperature ranges between 8 and 23 degrees Celsius. While there are some periods of missing data, the sea surface temperature observations can be seen to be not consistent throughout the year. This pattern can be seen with the half-hourly, daily, and monthly climatologies seen in this plot. During the summer, the sea surface temperature ranges between 11.5 and 16 degrees, while in the winter, the range is between 13.5 and 16 degrees. In most cases, the sea surface temperature should be warmer in summer than in winter, but as the summer is a period of strong upwelling in the southern Benguela, the surface waters have a colder signature. Because of the influx of cold waters, the Benguela is a highly variable system, and this can be seen particularly in summer. The daily sea surface temperature shows a similar pattern, with generally cooler waters in the summer and warmer values in the winter. This shows that there can be large changes within the sea surface temperature throughout the day. The monthly climatology shows that the upwelling season can be considered from October to the end of March. Moving forward, the term upwelling season will refer to the months from October to the end of March, and non-upwelling between the months of April to the end of September. Looking at the diurnal variability plots, the difference in the change in daily sea surface temperature between the upwelling season and non-upwelling season can be seen. The largest daily change can be seen in December, with a range of 1.1 degrees Celsius, compared to the smallest, which occurs in June, of 0.2 degrees. This indicates that part of the sea surface temperature variation can be contributed to the change in solar radiation. Only the Era 5 V wind component has been plotted here, as is a representation of the wind's variation. In the diurnal wind plots, the Era 5 wind has shown to have a diurnal variability, as seen over here. While the wind variation throughout the day can be contributed to the change in solar radiation, it will also have an impact on the sea surface temperature diurnal variation. By looking at the monthly averages, we can see that daily averages, we can also see that during the upwelling season, the wind has a tendency towards southward airflow, while the wind has a weak to northward airflow during the non-upwelling season months. These observations are consistent with the literature, as the southeasterly airflow generates upwelling and colder waters. Here is an example of a marine heatwave in the CSIR sea surface temperature time series in the Cape Peninsula cell. From the 20th of March, there are some periods of warm sea surface temperature, but the marine heatwave, according to the Hobday definition, only begins on the 25th of March and lasts about 10 days before the sea surface temperatures go below the 90th percentile. On the 3rd day of April, the sea surface temperature decreases from around 16 to 11 degrees in about a period of a day. Here in the corresponding V and U time series of Era wind. Here in the corresponding Era 5 wind, V and U time series, the wind turns southeasterly around the 1st of April, and the sea surface temperature decreases, indicating that it is most likely an upwelling event that resulted in the end of marine heatwave. Here are sea surface temperature anomaly maps to see the spatial progression of the marine heatwave. Plot A is just before the event, and warming already can be seen around the Cape Peninsula cell. Plot B and C show the sea surface temperature during the marine heatwave. The event seems to be contained to the southern part of the southern Benguela. Plot D shows cooling of the sea surface temperature and an upwelling signature over here. This event shows the possible influence of the connection of the Gullis current can have. This event shows the possible influence of the connection of the Gullis current on the Cape Peninsula cell and upwelling as a possible mitigator of marine heat waves. This plot represents the occurrence of marine heat waves in the half-hourly and daily CSIR and the daily CCI time series. While the three time series do have similar features, such as many of marine heat waves occur in the non-upwelling season during 2007, or the general absence of marine heat waves during the years around 2016 to 2018, the Heart Valley time series, which has the highest temporal resolution, only has 16 marine heat waves during the 17-year time series, while the daily CSIR has 31 and the CCI has 38. These plots show that the Benguela is a highly variable system, and in order to fully understand extreme warm events in the southern Benguela, perhaps a different definition and set of parameters is required. Going forward, I will be investigating extreme warm events and how they form in the Cape Peninsula upwelling cell. These plots show that as the Benguela is a highly variable system, in order to fully understand extreme warm events in southern Benguela, perhaps a different definition and set of parameters is required. Going forward, I will be investigating extreme warm events and how they form in the Cape Peninsula upwelling cell. Thank you for listening to my presentation. If you have any questions, please email me on the email address below. Thank you.